Welcome to the new AP Computer Science A series in Java. This is Unit 6 on arrays. If you want to jump ahead to a specific topic, check out the time markers in the video description. Also, I will be adding to and updating this series, so make sure to hit the subscribe button to keep up to date on all the latest content. Let's start by thinking about what a variable is. A variable is like a container. It can hold different things, like an int, or a double, or even an object like a string. However, it can only hold one value at a time. Now we introduce arrays, which are like one container with separate compartments. This would be considered an array of size 3 because it's got 1, 2, 3 compartments. We identify each compartment with its index number. So this would be index 0, this would be index 1, this would be index 2. And each of these compartments can hold a different value. Let's think of a time when it would be more efficient to use an array. Let's say we wanted to write a program that kept track of how many runs each team scored in a baseball game. So for a standard length game of 9 innings, we'd have 9 variables for the home team and 9 variables for the visitor. This could be doable, but this is a lot of variables to keep track of. On the other hand, if we used arrays, we could have one array for the home team with one index for each inning, and one array for the visiting team with one index for each inning. It's a lot more efficient to program and to debug. Now let's move on to see how we can implement arrays in Java. Arrays can hold multiple different values of the same data type in one variable. Arrays are objects, but their indexes may hold primitive types or reference types. Arrays in Java and most languages start off at index 0. Let's look at the two ways we can create arrays. First, we can declare the variable type, add a set of square brackets, letting the compiler know that this variable will point to a one-dimensional array, and have the variable name. Next, we say that we are creating a new, whatever data type, and then the number of indexes inside square brackets. This could be done on two lines where we declared the variable on one line and initialized it on the next. If we don't specify the values, in this case they will default to 0 because it is an int. If it were a double array, they would default to 0.0. If it were a Boolean array, they would default to false. And if it was any type of object array, the values would default to null. Another way to create an array is, again, variable data type, square brackets indicating a one-dimensional array, and variable name, and then set it equal to a hard-coded array. This array is size 4 because it has 4 elements, separated by commas, with curly brackets at the beginning and the end. Let's see how we can change the values inside an index. This command says we want to change index 2 of the array x is pointing at to 12. Index 0, 1, 2 is changed to 12. Let's look at another line of code. This is saying we want to change index 4 at whatever array y is pointing at to 21. 0, 1, 2, 3, 4. There is no index 4, so we're going to get an out of bounds exception and the program will crash. If we want to access data inside the variable, we do it like any other variable, except not only do we specify the variable name, but we specify what index we want to access. This line of code will print out whatever value is in y index 1. In this case, that will be 5. Next, we're going to review how primitive data types are stored in memory, and then we're going to look at how array objects are stored in memory and why that matters. For this demonstration, we've got 3 boxes. The first will represent our code, the second will represent the data structure of the stack, and the third will represent the data structure of the heap. Stacks start off at the bottom and go up to the top. However, when you are tracing your own code or code for a quiz or test, I recommend you start off at the top and go to the bottom because it makes things a little simpler. Our first line of code, we declare a variable a of type int and set it equal to 3. Since a is a primitive type, all data is stored on the stack. Next, we declare a variable b of type int and set it equal to a. Since they are primitive types, we simply copy the data from a to b, and b gets its own unique entry on the stack. Here, we modify b to equal 100. We simply change the entry on the stack for b to equal 100. Next, we're going to take a look at some reference type variables. C is a reference type variable. We declare C as an integer array. Integer arrays are objects. So, on the stack, we set C equal to a pointer to an object on the heap. The value of this object is an array of size 4 with values 1, 2, 3, and 4 in indexes 0, 1, 2, and 3. Remember, the only data stored in C on the stack is the pointer. Next, we declare a variable d, also of integer array type, and set it equal to C. We're going to copy the data from the stack to d. However, this simply means we are copying a pointer. Now C and D are both pointing to the same object on the heap. This line of code has us reach into the object on the heap and change index 1 to equal 99. Since C and D are both pointing to the same object, this ends up affecting both C and D. Here we are changing D again. However, we are causing D to point at a brand new object, an integer array of size 5. We move the pointer for D to point at the new integer array. C and D no longer have a connection because they are pointing at different objects on the heap. Here we are declaring another integer array, E, and having it point at a new object on the heap. Next, we create an integer array, F, and have it point to an identical object on the heap. Notice, even though the values are the same, they are separate objects on the heap. When we change the value in index 1 of the object F is pointing at to 98, it only affects F because E and F are pointing at different objects on the heap. Next, you'll learn about traversing an array, which is going over each index using a loop. Some important facts to know. Arrays in Java and most languages start at index 0. That means the first index will actually be index 0. Dot length will return the number of indexes in an array. Since the indexes start at index 0, that means an array of size 5 will have indexes 0, 1, 2, 3, and 4. You can traverse an array with a for loop or a for each loop. Let's start writing some code. Here we're declaring an array, x, and setting it equal to 2158. And here we can see the reference variable x on the stack and the array on the heap. Now let's write some code to traverse it with a for loop. So we see we're starting by declaring our counter variable, int I, and setting it equal to 0. We're going to continue the loop as long as I is less than x.length. So in this case, x.length is going to return 4 because this array has a size of 4. At the end of each loop, we're going to increment I by 1. I++ is short for I equals I plus 1. Inside the loop, we're going to print out x index I and then a space so all the numbers don't run together. So let's trace this out. We'll start by declaring I and setting it equal to 0, and that gets placed on the stack. Now we're going to check is I less than x.length. So 0 is less than 4, so this is true. We continue along with the loop. Then we print out x index 0, which is the number 2, and a space. We get to the end of the loop, so we increment I to 1. So now I equals 1, and we're going to be looking at index 1 on the array. We check, is I less than x.length? 1 is less than 4, so we continue. We print out x index I is 1, so we print out the number 1, which is in index 1, and then a space. get to the end of the loop, increment I by 1. Now I equals 2. We check, is I still less than the length of the array? It is, so we continue the loop. We print out x index 2, which is 5, and then a space. Now we increment I to 3. We check, is 3 less than the length of x, which is 4, so that's true. We print out x index 3, which is the number 8, and then a space. We increment I to 4. We check, is 4 less than the length of the array? So is 4 less than 4? It is false. So we terminate the loop. So now we've gone through the loop and we've printed out the contents of the array. Now let's look at some modifications we can make to the for loop. Here, we're incrementing by 2 instead of 1. So every time we get to the end of the for loop, we set I equal to I plus 2. So I'll start out at 0, go to 2, and then go to 4. Let's look at another modification. We could start out our counter I at 1. So we'd start by printing out index 1 and then continue on like that. Another modification we could make to this code is instead of printing out the data, we could modify the data. So here we're taking the data inside x index I, multiplying it by 2, and taking the product and returning it back into x index I. So if we ran this code, it would go through the array and double the data inside each index. Now let's look at a way to traverse the array using a for each loop. You can see a for each loop has two parts. The first part is a temporary variable. I named mine t. The temporary variable has to be of the data type that's inside the array. So since this is an array of ints, I've made my temporary variable an int. Then we have a colon, and then we have the name of the array, in this case x. A for each loop will go through one time for each index in an array. Each time it goes through, the temporary variable will hold the value inside each of the indexes. So the first time through, t will hold 2, the second time through it'll hold 1, and so on. So let's trace this out. We start by declaring t and setting it equal to the value inside index 0, so t equals 2. Now we're going to print off t and a space. Now we'll move t to index 1, so t will hold the number 1. Then we'll print off the value of t, which is 1. We'll go through again. T will take out the value 5. Then we print off the value of t. Our last time through, t will pull out the value 8. Then we'll print off the value t. There are some limitations to the for each loop. With the for loop, we could skip certain indexes, but a for each loop will go through all of the indexes in the array. Also, in a for loop, we are able to modify the data inside the indexes, and we can't do that with a for each loop. While a for each loop can be easier to use, its limitations mean it might not be appropriate in certain circumstances. Next, you're going to learn an algorithm for reversing the values in an array. An array can be reversed by swapping values in the first half with values in the corresponding indexes in the second half. This is the algorithm we're going to learn today. Values can also be swapped by copying values to the opposite index in a temporary array. However, this algorithm may not be allowed in certain free response questions in the AP Computer Science A exam. Let's write some code. We'll start by declaring a variable x and setting it equal to a new int array of size 5. Next, let's look at the algorithm for swapping. We have a for loop. We start off the counter variable I at 0 because arrays start off with their first index 0. Next, we go through half the array. X.length divided by 2, in this case, is 2 because an array of size 5 divided by 2 is 2.5. However, with int division, we lose the decimal portion of the number. At the end of the loop, we increment the counter variable I by 1. Inside the loop, we start by declaring a temp variable and copying the value from x index I into it. Next, we copy the value from the index opposite x index I into x index I. And then finally, we copy the value from temp into the index opposite x index I. Let's trace out this code to see how it works. We start by declaring a variable I and setting it equal to 0. Next, we check is I, which is 0 right now, less than x.length divided by 2, which is 2. This is true, so we can continue on through the loop. We create a temp variable and copy the value from x index I, which is in this case index 0, into the temp variable. Next, we copy the value from the index opposite x index I into x index I. Finally, we copy the value from temp into the index opposite x index I. At the end of the loop, we increment I by 1, bringing I to 1. We check, is I still less than x.length divided by 2? It is, so we continue. We create the temp variable and copy the value from x index I, which is in this case 1, into the temp variable. We copy the value from the index opposite x index I, in this case index 3, into x index I. And finally, we copy the value from the temp variable into the index opposite x index I. At the end of the loop, we again increment I to be 2. We check, is 2 still less than 2? This is no longer true, so we terminate the loop and continue on with any code afterwards. Next, you'll learn an algorithm to find the largest number in an array. You can modify the code slightly to instead find the smallest number. So I've created a class, I called it findLargest, and then I made a basic main method here. Inside the main method, I've created an array of ints. I've got some values here. The first thing we have to do is we have to create a variable. I'm going to call it largest to hold the largest value. Now I've made the variable an int because it's an array of ints. If this were an array of doubles, we'd make largest a double type variable. Now we have to set it equal to something, so we're going to set it equal to the first value because we don't know what the largest is going to be. So the good place to start is with the first value, which is at index 0. So we're going to say an array index 0. So after this line of code, largest will be equal to -2. Now what we have to do is we have to make a for loop to traverse the entire array and look for something larger than -2. So we're going to say for. We'll start our counter variable I at equal to 0. We'll continue as long as I is less than an array.length. Notice there's no open close parentheses after that. Another semicolon. And at the end of each loop, we'll say I++. So we'll increase I by 1 every time we go through the loop. Let's make an open and close curly bracket to show where the loop begins and ends. Now what we need to do is we need to check each value in the array to see if it's larger than what largest currently is. So I'm going to say if an array index I. So I will be changing as we go through this loop. So it's going to start off here and then there and then there and all the way through the loop. If whatever's in index I of an array is larger than what's currently in largest, then we have to change largest. So we're going to say largest equals an array index I. So we'll start off with largest equal -2. Then we find, one's bigger, so we set largest equal to 1. Then we go to 6 and we say, 6 is even bigger, so then we set largest equal to 6. And we keep doing that until we go all the way through the array. So now at the end of the for loop, largest is in this case going to equal 10 because that's the largest number in this array. So let's print out that value. So we're going to say system out print line, and we'll say largest. So let's run this and see that we get the 10. So we'll say run, and there we go, it's 10. Now I'm going to change this up a little bit. I'm going to make the 6 60. So now I'm going to run it again. And now the largest is 60. So that's how we can find the largest value in a Java array. Thanks for watching. Please hit the like button and then leave me a comment down below. To see the next video, click on the image on the left side of the screen. To see the entire playlist for the series, click on the image on the right side of the screen. And to keep up to date on all the latest content, hit the subscribe button in the middle.